Today we're going to look at some applications of linear equations and also start looking at inequalities. What we want you to be able to do is identify independent and dependent variables in a linear equation, be able to calculate out average rate of change, and solve basic inequalities. Independent variable. In most cases, we use x as the variable for independent variables. X is the domain, and we'll talk as we keep going here in this class what the domain is, and it's also your input. It's what you put in to get out what's called the dependent variable, and that usually is represented with y. Y is your range, and again, as we go, we'll talk about what range is. It's also what you get out. So you're going to input something, and then you get an output. The input is your independent variable. Your output depends on what your input is, so that's the dependent variable. We're also going to be looking at rate of change. When you want to find the average rate of change, that becomes your change in y over your change in x. So to find average rate of change, it's your change in y over change in x. If you have 2 points, then that's your difference in y's over your difference in x's. Okay, and a lot of you should recognize this. That's your slope formula, because slope is the same as average rate of change. So anytime you hear the term average rate of change, that's the same as slope. Okay, so in example 1, it says that Lynn is tracking the progress of her plant's growth since she bought it. The growth is modeled in the table. What is the average rate of change for the plant's growth per day? So if we want to find average rate of change, again, that's like slope, we want to have 2 points. Okay, so we're trying to pick out what are the 2 things. And here we could pick 2 points. Our independent variable is x, our dependent variable is y, the height. Pick 2 and it doesn't matter. These might be the easiest 2 since we don't have to deal with decimals. Let's find the average rate of change. So average rate of change or slope is change in y over change in x. Okay, now you gotta be careful here. We don't want to do 2 minus 4 and subtract those on top. Those are not our y values. Our y values are the bottom ones, what we get out. So we'd want to do 9 minus 6, our height, divided by our days, and if we subtract those, we get 3 over 2, or that's also the same as 1.5. And so what's that telling us is, on average, the plant is growing 1.5 centimeters per 1 day, per day. So that's the average growth, is 1.5 per day. And if you look at the table here, we can see that it's going up on average here, 1.5. Every time it's increasing by that. Okay, B, write a linear model that represents the height of the plant after D days. Okay, so if we go back to our point slope form, we can do this now. We know that our average rate of change, or our slope, is 1.5. We got a couple different points we could choose here. I'm just going to pick the first one. So we know one set of points on our table is at day 2, we have a height of 6. If we use that now with our point slope form, we can easily calculate out what that linear equation would be that would do that. So put in our average rate of change, or slope is 1.5. Put in our points here. Do a little solving. Remember, you got to we want to get this in slope intercept form, so we got to do some distributing. 1.5 times 2 would be 3. And then we want to add 6 to the other side. Adding 6 to negative 3 would give us positive 3. And so this is an equation now that models what the table is saying. Again, what does our 1.5 mean? It means it's growing 1.5 centimeters a day or per day. What does our 3 mean? The 3 there, that's our y-intercept. And y-intercept, what it tells you is what is the, in this case, height at day 0, or basically what it was our height at the start. Okay, so the height originally was 3 centimeters, and it keeps increasing 1.5 each day. And if we keep doing that, we get these values in the table up here. Okay, second example, Kevin's savings account balance should be changed from 1,140 in January to 1,450 in April. Find the average rate of change per month. Okay, so you can see here per month tells us we want months on the bottom of this. So we want to have months on bottom, and we want to have the money on top. So when we're subtracting these, we want to have the change in the dollar amount on top. Okay, so let's subtract the dollar amounts on top here. And then we want to have the corresponding months on the bottom. Now, the months here, they don't have a number to them, but we could associate them with some numbers. Usually we say that January is the first month, and then if we keep counting, February would be the second, March would be the third, April would be the fourth month. So if we put those associated numbers with it, we would have the months here 4 minus 1. Or that's telling us that it's over if we subtract those 3 months. If we subtract the top, we get $310. So if we take $310 divided by 3, we find out that it's 103.33333, or $103.33 per month change. On average, that's how much this is changing each month. Okay. And since it's going up here, we can see that this is increasing by that amount. Okay, example 3. Marty is spending money at the average rate of $3 per day. After 14 days, he has $68 left. The amount left depends on the number of days that have been passed. What are the independent and dependent variables? Okay, so if we want to answer that, remember independence like your input. Okay, what changes? So our independent variable here would be the number of days. Okay, because that's what we input, and then our output would be our dependent variable. That's what we get out, and in that case, this would be the dollar amount, the amount of money here, the number of dollars. Okay, so for part B, let's see if we can figure out what is the average rate of change for this situation. Well, the last couple problems we've had to use like a table or some information from the problem to get that. I think here they actually tell us right in the problem that on average rate of $3 per day. Now we do have to look at some of the words on this one. It says Marty is spending money. If he's spending money, he's not putting money into his account, he's taking it out. So it looks like for this, it's decreasing $3 per day. So our average rate of change, or our slope here, would be -3. It's going down 3 each day. Okay, part C, write an equation for this situation. Okay, so we know, again, our slope is -3, but we need something else to go with that. And here's the last part where this comes in. It says, after 14 days, he has $68. So if we know that our days are our X value, our independent value, that should go first, so 14. The dollar amount is our dependent, our Y, that should go second. So we got the point 1468 that goes with this. Now you can put it in our point slope form, and we should be able to calculate out the equation. So going through and doing a little math here, distribute. Negative times a negative is going to be a positive 42 here. And last step, we want to add 68 over. And so it looks like our equation we'd get would be y equals negative 3x. If we add 68, you'd get 110. Okay, so for this problem then, for part D, they want to know how much money did Marty start with? So if we want to answer that, how much money did he start with? That is told by our y-intercept. Okay, he started at $110 and then keep spending $3 a day. That takes us down to this situation where after 14 days, he's down to $68. So the y-intercept always tells you your beginning amount of your dependent variable. All right, next example. Suppose a 5-minute overseas call costs $5.91 and a 10-minute call costs $10.86. The costs of the call and length are linearly related. What's the independent and dependent variables? Okay, why don't you pause the video and see if you can pick out which ones those are. All right, our independent variable here would be what you would input, which would be the number of minutes. What we would get out then, once we know the number of minutes, that would be our dependent variable. And in this case, that's going to be our dollar amount, our money, our cost. All right, part B, what is the average rate of change for this situation? Be sure to label the rate of change. Okay, so they never specifically told us in this one, but we do have some call links with associated costs. Pause the video and see if you can figure out what this is going to be. All right, let's see. We got some different things here. They said a 5-minute phone call costs $5.91. They said a 10-minute call is $10.68. We can find the average rate of change here using the slope formula. So if you went through and subtracted these and subtracted the call lengths, you should have gotten this to come out to be 495 over 5, which is the same as 99 cents per minute on this one. So that's the average rate of change, 99 cents per minute. Okay, part C. Now they want us to figure out what is the cost y of a call of X minutes during this duration. So if you wanted to come up with an equation that would tell you the cost at any amount of time, what would that be? Here's where we come up with an equation again. Pick one of these 2 points. It doesn't matter which one. I'm going to pick that one. We got our slope here. Use point slope to figure that out. Again, why don't you pause the video here and see if you can come up with that. All right, let's see. We got our slope of 0.99. We got our point here of 5.91. If you put it into point slope form, and remember you can use slope intercept form too. We did that on a previous video, but I'm going to continue with this here. You got 5.91 equals our slope times this, multiplying that out and distributing. On this side, we give you this. And now we got to add over that $5.91. So you get the equation 0.99x plus adding 591 to a negative 495 would be 0.96. So that would be our equation there. All right, for part D on this problem, now they want to know how much will it cost you to make a 22-minute phone call. Okay, well, that should be very easy now that we know the equation here. We got that 0.99x plus 0.96 is the equation for any call. Okay, remember our x is our independent variable, which is the number of minutes. So if we know that it's a 22-minute phone call, all you got to do is substitute in 22 in for x, and you can figure that out. And if you use your calculator, this should be pretty easy. Comes out to be that it's going to cost $22.74. Pretty expensive phone call. All right, last part, E. How long can you talk on the phone if you have $12? Okay, so now we're looking at dollars. That's our dependent variable, um, which in this case is our Y. So we want to use that same equation that we had before that models the situation, and now we're putting 12 not in for X, we're putting it in for Y because that's the cost. So you're putting 12 over here, and now trying to find X, which is the number of minutes that you could call. So now we're solving a little bit different here. First step, looks like we'd want to subtract 0.96 from both sides. So now we got 0.99x being equal to 1104. Divide both sides by 0.99, and we should be able to figure this out. And what you get here is that x would be equal to about 11.15 minutes. It doesn't look like we can quite get to 12 minutes here. So if they make you pay for each number of minutes, it looks like 11 minutes would be the most amount of minutes that we could talk there before we'd run out of money. All right. The other thing we're going to look at is start getting into solving inequalities, and we'll kind of continue with this on later lessons. Inequalities, those are those less than, greater than signs. So greater than looks like that, pointing at the smaller thing. Less than would be this symbol pointing at, again, the lesser thing being on the left. You can also have greater than or equal to, so that means it could be bigger or equal to the original number, less than or equal to as well. When solving any of these inequalities, you solve it just like an equation, except if you multiply or divide by a negative number. Then you must reverse the inequality symbol when solving. Okay. Some other stuff that you should know when graphing these, anytime you have greater than, like here's an example, x greater than 2, you want to use an open circle to graph that. So this one would be graphed as this. You would use an open circle, and then as long as your variable's on the left there, greater than would be all the numbers to the right. You can just kind of follow the arrow. On the next one, greater than or equal to, on greater than or equal to, then we fill the circle in. So graphing this one out would also be at 2, except here now we're filling in that circle and going to the right. Less than, it doesn't have that equals to sign, so again we'd leave it open. On this one, if we're less than, now we're going to the numbers less than, which would be to the left. So going out that way. If it's less than or equal to, again equal to, now we want to fill it in again. So if we're graphing this one, we got 2 filled in, less than again would be the numbers going left. Okay, so let's solve and graph a couple of these. Number 5, if this was an equation, our first step, try to get the variables by themselves. They already are, then try to get the numbers on the other side. To do that on here, looks like we'd minus 9. Okay, so now we got negative 5x on the right. Subtracting 9, we get negative 15. Divide by negative 5. Okay, so that's going to cancel those out. So we just got x on the right. Negative divided by negative would make positive 3 on the left. Okay, here's that one change. Anytime you divide by a negative with inequality signs, you got to switch the direction of the arrow. So now it needs to point that way. Okay, to graph this, okay, you got 3 is less than all the numbers. Or usually when we do these, our variable is on the right, our number's on the left. You can switch these around, but make sure your arrow is pointing the same way now. We're pointing at the 3. We want to continue to point at the 3 with our open end to the x like it was in the previous statement. So now to graph this, find where 3 is. We would use an open circle because it's not equal to. and then we would graph everything to the right because numbers greater than 3 are to the right. All right, let's try another one. Number 6, we want to solve this. Okay, again, get everything to the other side. Start by subtracting 1. Okay, so now I got 2x minus 6 over 5 greater than or equal to negative 1. Now, we can't really do anything with this numerator until we get rid of the division. Opposite of dividing is to times, so let's times both sides by 5. That eliminates that. So we got 2x minus 6 greater than or equal to. Now we times by a number, but it wasn't negative, so we want to keep the symbol the same way. Negative 5. Now this is pretty standard after that. We got some adding. We got some dividing. We're good. Now we're dividing by positive. No need to change anything. We can keep the symbol the same way. And we get that x should be greater than or equal to 1/2 or 0.5. So now on our graph, label where 1/2 would be. Okay, sometimes maybe if you got halves like this, you could go like 0, 1, and just go every other. So half would be right here. We'd want to fill this circle in because it's equal to. Numbers greater are going to be to the right. All right, last one. Again, solving here. Now you got some distributing you'd want to start with over here. So doing that, we would have positive 24 because we're multiplying two negatives minus 12x. Okay, now you just got to pick a side to move stuff to and go from there. Decision's really up to you as long as you're doing the opposite. I'm going to pick to add 12x. You could have picked something different if you want. So that's going to be 13x minus 15. That is less than 24. Now get the numbers opposite, so get them to the right. 13x is less than 39. Divide by 3. We're dividing by a positive. No reason to switch the sign. Everything less than 3 on your graph. Again, make sure you label where 3 is going to be at. Decide if it's open circle or closed circle. No reason to fill it in here because it's not equal to. Less than is going to be going that way. All the numbers less than 3 are that way. All right. Try some of these out now on your